Hi, I'm Mark Neiman Ross, and welcome to this week's edition of Raspberry Pi Weekly. Every week, we explore the Raspberry Pi and share useful tips. If you learn to program on a desktop or laptop computer, you may not be familiar with using interrupts instead of polling. Desktop programming environments rarely support interrupts, but that's where the Raspberry Pi differs. With the Raspberry Pi GPIO, you can react to these interrupts in a way you can't with other computers. Let's spend a bit of time exploring how to use interrupts with Python. If you're not clear on the difference between interrupts and polling, I highly recommend Baron Stone's chapter titled Polling and Event-Driven Programming from his excellent Programming Foundations Real-World Examples. For this discussion, I've created a circuit with an HC SR04, an LED, and a simple push button. I've included a handout that describes how to build this project. This project is an intrusion detector with a panic button. If an intruder comes within range of the HC SR04, the circuit flashes the LED to scare the intruder off. But sometimes the intruder sneaks around the HC SR04. The push button will manually trigger the LED. I know, very scary. I've written two software examples for this project. One uses standard polling, the other uses interrupts to accomplish the same task. Here's the polling example. First, there is a bit of setup. I import the necessary libraries, and you can see that in line 3 and 4. Then I instantiate the devices. In line 6, I define dsense as equal to the distance sensor, a button as equal to button on GPIO line 16, and the LED as an LED on GPIO line 12. I've created a function that flashes the LED. One pattern for the distance sensor, HCSR04, and a different pattern for the push button. Next is code to poll the rangefinder and the push button. There are sleep and print statements in the loop because I noticed that the ultrasonic sensor needs time to reset. If there isn't an intruder, the program checks the push button. If it isn't pushed, the program goes back and checks the distance sensor. When this program is run, it displays the sensor value and status of the push button. If an intruder appears, the light flashes. If the intruder avoids the sensor and the button is pushed, the light flashes in a different pattern. If I push the button during the 3-second delay for the sensor reset, nothing happens because the program is polling, it missed the event. Now, let's look at the interrupt version. The first lines are similar to the polling example, just importing libraries and instantiating devices. The code is slightly different because we're setting up an interrupt system instead of a polling system. Next is the function to flash the LED. It performs the same tasks as the polling example, although it detects the device in a slightly different way because of the interrupt code. Finally, lines 18 and 19 set up the interrupts. There are 3 parts to each line. Let's start with line 18. The first part is the device, in this case, dsense, which is the instantiation of the distance sensor. The second part is the event. In this case, I've chosen the When in Range event from the list of events available for the distance sensor. The third part of the line says to call the intruder alert function when something is in range. There is a similar setup for the push button. Running this program does the same thing as the polling program, but you'll notice 2 things. First is responsiveness. If I push the button while the distance sensor is responding, I receive an immediate reaction. The LED changes its blinking pattern. The second thing you'll notice is how the code has become cleaner. Rather than burying the logic in a try-while loop, the intent of the program is summarized in 2 lines of code. If something is in range, flash the LED. If the button is pressed, flash it in a different way. Interrupts are one of the strengths of the Raspberry Pi, and something you can't readily experiment with on the laptop. Thanks for joining me for this episode of Raspberry Pi Weekly. Be sure to join the LinkedIn group and check out previous episodes on LinkedIn Learning. I'll see you next week with more Raspberry Pi adventures.